In this video lesson, we are going to cover the second part of chords and arcs. So to recap, the degree measure of a circle, and this is from last semester, the degree measure around a circle is 360 degrees. Therefore, the degree measure of a semicircle, ACD right here, would be 180 degrees. 360 divided by 2, which is 180. To find the degree measure of an arc, all right, if we have minor arc CD and it's 45 degrees, then the central angle P is also 45 degrees. Okay, so the arc is always the same as its corresponding angle. So here we have arc CD, its associated central angle is 45 degrees. To find the major arc CAD, right here, CAD, you would just subtract 360 minus 45. Since we know the whole circle has to add up to 360, we would just take 360 minus 45. You can also measure an arc by its length. Okay, so there's actually two ways to measure an arc. There's the degree measure and then there's a length measure. The way you measure the length of an arc is you take the degree measure first and you divide it by 360 and then you multiply it times 2 pi r. Okay? If you remember, 2 pi r is the circumference of a circle. So that's how we can find the length, because the circumference tells us what the whole circle equals. So if we take the measure of the arc and divide it by 360, it tells us the portion, right, the fraction that takes up this part of the arc, and then we just multiply it times the circumference, which will tell us the length of the arc right here. Chords and arcs theorem. It says in a circle or in congruent circle, the arcs of congruent chords are congruent. Okay, so for example, if we have circle C right here, okay, and then we have line RS and line DF. Okay, these are both chords, right, because they have their endpoints on the edge of the circle. These two lines tell us that they're congruent. So since we know that RS and DF are congruent, then we also know that the associated arcs, that arc RS and arc DF are also congruent. So that's the chords and arcs theorem. So here we have circle A, and it has diameters ED and FC. So here we want to name all of the congruent arcs and then explain why those pairs are congruent. Okay, so here we can say, if we notice, let's talk about this question first. Why are the pairs congruent? All right. Now here it doesn't tell us that these chords are congruent. Okay, but we do know that these are vertical angles right here. Right. Okay, so we know that these two angles are equal to each other. So that means that these two arcs have to be congruent to each other. So we can say that EF is congruent to CD. All right. Now, we can also know that a diameter, right, or a straight line has a 180 degree measure. Okay, so we can also say, since this, here we have ED, so we know that arc EFD has 180 degrees measure. And if we look at this other diameter, FC, okay, then that tells us that FDC is also 180 degrees. So we know that those two arcs are congruent. Okay, we also know that these other two minor arcs here across from each other, so minor arc EC is congruent to minor arc FD as well. So those would be congruent arcs. Here it says that EF is a diameter of circle D, right, because it has its endpoints on the circle and it's going through the middle. And the measure of angle GDE, right here, is 105 degrees. What is the degree measure of arc FG, right here? Okay, so it's talking about the degree measure, which means that if this is 105 degrees, then this is also 105 degrees. So arc FG is going to equal 105 degrees. Okay, if it asks for the length, that means it's asking for a number, but a degree measure means it's asking for the degree. Here it tells us in circle P to find the length of arc BD. Okay, so the length now we're going to find a number if the diameter of AD is 12 inches. Okay, so remember, the length of an arc is the measure of the arc divided by 360 times 2 pi r. So the first thing that we have to find is the measure of this angle right here. Okay, that would be the measure of angle BPD. Now, since we know that this is 100 degrees right here, this angle plus that angle, right, APB plus BPD is going to equal 180. So all we have to do is take 180 minus 100. So we know that this is 80 degrees. So because this is 80 degrees, we also know that arc BD is 80 degrees. So that gives us a number to put in there, 80 over 360 times 2 pi. And then here it tells us the diameter is 12 inches. So we want to put the radius in of 6. Okay. So now what we want to do is reduce down as much as we can here. Okay, so if we take 80 over 360, our zeros can cross out. Okay, so this actually 8 and 36 will both be divisible by 4. Okay, so 8 divided by 4 is 2. And then 36 divided by 4 is 9. So we have 2 over 9 times, and then here we have 2 times pi times 6. 2 times 6 is 12, so we have 12 pi. So now we have 2 over 9 times 12 pi. So let's take 2 over 9 times 12. 2 times 12 is 24, so we have 24 over 9 pi. So now let's take 24 times pi, and we'll just use 3.14, which is 75.36, and we'll divide it by 9, which is going to give us approximately 8.37. So our arc length for BD is going to be approximately 8.37 inches. All right, on this one, it says if the measure of angle GDF is 55 degrees, what is the measure of arc EH? All right, so if we notice here, see how we have this, see how we have these two chords right here that are congruent? That tells us that these two arcs are congruent. Remember our chords and arcs theorem earlier? Okay, so that means that arc GF is congruent to arc EH. So since this is 55 degrees, we know that GF is 55 degrees, so we know that EH is 55 degrees. So arc EH, the degree measure, is 55 degrees. Here it says if the measure of angle CDE is 120 degrees, what is the measure of angle arc EGC? Okay, so we're wanting to know this arc right here. Okay, so if this is 120 degrees, right, then we know that the arc right here, EHC, that arc is 120 degrees. So we know this all has to add up to 360. So what we would do is take 360 minus 120, which is going to give us 240 degrees. So that would be the arc measure of arc EGC. Excuse me, the degree measure of arc EGC. Okay. This last one says if the measure of arc EH, okay, so here we're not going to have 55 anymore, we have a different number. Okay. If the measure of arc EH is 43 degrees, what is the measure of the obtuse angle GDF? Okay, and so what that's saying, and I'm just going to go ahead and erase my ink because that So I think that'll help us out here. Okay, so here we have EH is 43 degrees. All right. So it wants to know the measure of obtuse GDF, because here if we look at GDF, this is an acute angle. So what it's asking us for is this angle right here. Okay. Now, just like we had earlier, right? If EH is 43, I know that GF is 43, right? And if I know GF is 43, I know that this interior angle right here is 43 degrees. So I know that this whole circle has to add up to 360. So all I'm going to do is take 360 and I'm going to subtract it from 43. And that's going to give me the obtuse angle of GDF is going to equal 317 degrees. And that is the end of chords and arcs part 2.